I will tell you that Chapter 8, there are some formulas that you're going to have to know. Today's not one of those days where you're going to have to learn some of those formulas, but there are a bunch of formulas that you're going to use eventually later on in Chapter 8. But today's more about some notation and some vocabulary and getting familiar with the difference between a sequence and a series and kind of going. So, one was sequences and series. We did not talk about series today. We will talk about series when we go over day 2. Okay? Let's talk about what a sequence is. Today's focus is really going to be on sequences. A sequence is just a bunch of numbers. There's some kind of progression to them. There's some kind of pattern usually, but it's going to be a list, almost like a set. But instead of just being a set of sort of random numbers, there's going to be something relatable between all the numbers. Usually, like I said, there'll be some kind of pattern. And later on in 8.2 and 8.3, we'll talk about 2 specific types of sequences. But today, it's just going to be a bunch of numbers, and you're going to have to kind of recognize the pattern. And today's more also about getting used to the notation, because the notation is going to be something that you have to be familiar with. Here, there's a lot here. If you want to take a picture of this page, you can. But I want to go through what everything means here and what all the notation means, the definitions, okay? So we're talking about, this is the nth term. A sub n is known as the nth term of the sequence, because there's going to be a bunch of terms, like I said, almost like a set, which is why it's in braces. So it's a set of numbers. This notation, when it's in the braces like that, means the entire sequence. If it doesn't have the braces, it's just saying the nth term. But when you put the braces around it, you're saying the entire sequence of all the different elements, right? And so the way it looks is A sub 1 is the first term. A sub 2 is the second term. A sub 3 is the third term. And then, whatever the nth term is. And then in this case, it could go on forever. It doesn't always go on forever. Sometimes it will end. And A sub n will be the nth term. If there were 100 terms and this ended up being the 68th term, then you'd have A sub 100 would be the last term. But that's what this notation means. And again, we're going to go through some examples so you can see what I'm talking about. There's going to be some kind of pattern to get from the first term to the second term, from the second term to the third term to the fourth term. And generally speaking, the thing that you're going to like least about this section is there's a lot of writing to be done and some calculations. The calculations aren't necessarily going to be hard, but you're going to have to come up with 3 or 4 or 5 different terms. And so you'll have to do some arithmetic to come up with whatever those terms are. Are there any questions about the notation or what we're seeing up here? And the other thing that I would say is the nth term it's just some term in the sequence. And sometimes n will be defined for us, sometimes it won't be defined for us. Okay? All right. So some of your problems will look like this, where it says, write the first 4 terms of the sequence defined by the nth term. So they gave us a little formula here. A sub n equals 3n squared minus 4. And what this means and what we do is actually really straightforward. Okay, so we're finding the first term, the second term, the third term, and the fourth term. Which means, so if we're finding the first term, the second term, the third term, and the fourth term, we're looking for when n is 1, 2, 3, and 4. Because we're going to find a sub 1, a sub 2, a sub 3, and a sub 4. Well, what we're saying is n is going to be different for each term, and then we're just going to plug that in. So for the first term, we're just going to plug 1 in for n. For the second term, we're going to plug 2 in for n and simplify that. And until you get all 4 terms. So here's the way I like to set this up. Now, I don't necessarily think you need to write a sub n again, but that's going to be your formula. All right. So notice that the subscripts are in pink because that's what we're going to substitute in for n. So for the first one, we just plug 1 in. Okay. Again, we don't need this again. I should have erased that. Okay, so I plug 1 in for n, and I simplify. Remember, you do powers first. Don't give me 3 times 1 and then square that. That is wrong. You have to do exponents first. So this is 1 squared times 3, which is 3, minus 4. So this is 3 minus 4, which is negative 1. Go ahead and finish A2, A3, and A4 for me, please. There might come a point when you can see the pattern, and then you don't have to do the calculation. If you're confident that you know what the pattern is, then you can find like the third term and the fourth term if you establish what that pattern is. I would say in this case, maybe by the fourth term, because 1 to 2, 2 to 3, you get a couple in there where you feel like, okay, now I see the pattern, but in this case, I'm not sure that you can do that. But that's something you want to look for, because pattern recognition is a big part of sequences, and it's going to make your life a little bit easier. All right, what did you get for the second term? 8. Okay, that's what you should have gotten. Plug 2 in. All right, how about the third term? Say again? 23. Do we see a pattern? Like this one goes up by 9. This one goes up by 15. I don't know what kind of pattern you might see from that. So we might as well just plug it in. So what do you get for the fourth term? 44. So it goes up by 9, by 15, by 21.
It goes up by 6 every time.
So right. So that's so this one, since it goes up by 9, this one goes up by 15, this one goes up by 21. What's the next one going to go up by? 27. Okay. So look for those kinds of things, all right? Keep in mind when you do your homework, this notation is important, okay? I want to see a sub 1 equals negative 1. So when you do this, you know, for some of them you might not have to show work. So if you just wrote it like this, especially if you recognize the pattern. Don't just list them. When it specifically asks for the 4 terms, put the A with the subscript that goes with it, okay? Any questions about that part of this? Okay, let's jump to the next part. Okay, now in this case, this kind of problem, we are looking for a specific term of a sequence. So here's the formula that they're given. The sequence defined by b sub n equals n squared over n plus 1 factorial. Remember factorial from statistics, hopefully, when we did factorial. Find b sub 6. So all I need is the 6th term here. I don't need the first 5 terms. I don't need to figure out my way to it. I just need the 6th term. So what do you suppose I'm going to do here? Plug 6 in for n. That's it. So go ahead and do that one and see what you come up with. I want your answer as a fraction. Fraction, not a decimal. See, let me work through this one because I want to show you how an easier way to work through this rather than relying just on your calculator, which you can do, but let me show you, okay? So I substitute 6 in. Okay, so on top I get 36. 7 factorial. Now instead of actually figuring out 7 factorial, I'm going to find a way to do some canceling, okay? So let me show you. Whoa, where did you say you wanted it? There it goes. Okay. No, I do want it as a fraction. So 7 factorial we know is 7 multiplied down. Okay, if I can find a way to come up with a 36 out of the numbers that are on the bottom, then I can cancel it with 36 on top. So if I have 6 times 3 times 2, that'll give me 36. Okay, which means I can cancel them all out. which makes your numbers a lot smaller now and more manageable, and something you can probably do without a calculator, because this is just 20 times 7, which is how much? What is 20 times 7? 140. So on top there's nothing, which means there's a 1. So 1 over 140. And that's my answer. Okay? Again, the way I want you to do problems like this is I want you to leave them as fractions, should you come up to a problem like this in your homework. All right? We've got one more thing to do, and this is also a little bit new, and we need to talk about how to make this work. Okay? So this is, if you're given a formula, you can find the values. That's one way sequences work. Another way sequences work is you need the previous term to come up with the next term. And so in order to find the 6th term, I need the 5th term first. In order to find the 10th term, I need the 9th term first. When you have a formula like that, a situation like that, we're talking about a recursive situation. Okay, and when we're talking about a recursive situation or a recursive formula or a sequence defined recursively, we're saying we need the term before it to come up with the next term. And in order to do that, we need a couple things. First off, we have to have a starting point. And when that happens, so I'm given the very first term, so I know where to start. In order to come up with the second term, in this case it wants the first 5 terms. So I need the second term, the third term, the 4th term, and the 5th term. They've already given us the first term. So it's not 5 more, it's the first 5. So they've given us one of the answers. Now, what I really want to pay attention to is this notation. Okay, so here I've got a sub n, whatever the nth term is that I'm looking for. What this says is 2 times, this particular form is 2 times a to the n minus 1. Okay, all that means is the term right before the nth term. Okay, so it would look, if I was writing a sequence out, if this was the nth term, the term right before it would be a sub n minus 1. And let's think about that for a second. If I had the 7th term, what's the term right before it? Just the 6th term. What's the term right before that? The 5th term. Okay? So in other words, if I subtract 1 from this, I get this. If I subtract 1 from this, I get the term right before it. So if I subtract 1 from n, I get the term right before it. So when you see this a sub n minus 1, all it really means is the term right before the nth term. That's all it means. Okay. So in other words, like I was saying at the beginning, in order to find the nth term, I need the term that's right before it. Okay? So in this case, the first term that I'm going to have to find is the second term, because they've already given us the first term. Well, if I'm trying to find the second term, I need the term right before it. Well, what is the term right before the second term? 4, the first term. Okay? So that's what a recursive formula is saying. Okay, there's a couple things here. N has to be greater than 1, because if it wasn't, we'd have it a sub 0, and we don't know what to do with that. So here's how this works. All right. So the first term is given to us. Fine. Now I have to use the formula to come up with the second term. And here's what that's going to look like. Again, here's all of this that I was just talking about. If you want to write it down, you can. This is the nth term. This is 2 times the term preceding, the value preceding term, the term right before the nth term. So I'm going 2 times that previous term plus 1. And that will give me whatever term I'm looking for. So in this case, okay, the second term is 2 times the first term. Again, n in this case is 2, n minus 1 is 1. Well, I know the first term. First term is 4. So I just plug it into the formula. So the second term is 9. So now in order to find the third term, what value am I going to plug in?
9.
9. I'm going to plug this term that I found, because in order to find the third term, I need the second term. In order to find the fourth term, I need the third term. In order to find the fifth term, I need the fourth term. So here's where that recursive relationship occurs. So now for a sub 3, I take this 9 and I plug it in now. Now it gets plugged in into the formula, because to find the third term, I need the second term. Okay? And that ends up giving me 19. So in order to find the fourth term, I'm going to have to plug in 19. And that cyclical kind of feeling that you get where you take the one value and plug it into the next one, and then you just repeat that process, that's what a recursive formula is about. Okay. So I need to do this for a sub 4 and a sub 5, so go ahead and do that. So I plug 19 in, go through the same thing. The fourth term, 2 times the third term plus 1. So the third term was 19, that's 38 plus 1 is 39. Now for a sub 5, same thing, 2 times the fourth term, that was 39, that's 78 plus 1, 79. Okay, so there are your first 5 terms. 4, 9, 19, 39, 79. Now I know in the other problem I said, well, you write a sub 1, a sub 2, a sub 3. Well, we did that over here. So if you want to make a nice little list at the end because you feel better about making a little list, that's fine. So long as you have this here to begin with, a sub 2 is 9, a sub 3 is 19, a sub 4 is 39, and a sub 5 is 79. If you want to put a bow on it by listing them in order, you can. Or you can stop right here. It's up to you. Okay? But that lists me the 1, 2, 3, 4, 5 terms. So that's recursive. Again, if it asks for a recursive, you have to use the previous term to come up with the next term. And that's what this little notation means. Okay? Are there any questions about any of that? All right, that is day 1. We'll work on day 1. Then day 2 will be series. Obviously, I talked about at the very beginning.